Hi, this is Stelios from the Tesseract Academy. In this video, we're going to talk about data science in marketing. Marketing produces lots of data. So we have data around performance, such as the performance of ads or products, but we also have data that describe a user, their interactions, the past interactions with the brand, the demographics, etc. It makes sense that many techniques from data science, coming either from statistics or machine learning, have their applications in a field like marketing that produces so much data. In this presentation, we're going to talk about some use cases around the use of machine learning and statistics in the context of marketing. The use of data science in marketing, it's a relatively new thing. So there are many things which are not standardized. There are many applications that might overlap with traditional business analytics. We're in a situation where people in the space of marketing are still trying to get in terms with things such as predictive modeling, optimization, or reinforcement learning. I hope that this video will help you understand some of these terms better. So let's start, and let's see our first use case. We're going to talk about conjoint analysis. That's a very traditional application of statistical analysis in marketing, and there are three main steps in this process. The marketing analyst will present different product profiles to consumers, and the product profiles are defined by their attributes. The customers then rank or rate these products in terms of preferences. Our goal is to find how each feature affects the preferences of the users. So here is an example of this technique in practice. You can see here different phones and mobile packages, and there are some variables such as the brand, the startup cost, the monthly cost, etc. And you can give this to someone and ask them to rank the different services in terms of preference, which one they would first go with, which one would be second, etc. So the goal of conjoint analysis is to analyze each individual variable and then produce a score for each one, and the scores are centered on 0. This means that we want to see how much a variable adds or subtracts from the ranking. So the reason we do this, the reason we center at 0, is interpretability. Doing this makes it easier to understand the results, and we can see, for example, in this graph, that having a monthly cost of $100 in this case is a very positive factor. It increases the ranking of a package. Having a high cost, as it would be expected, reduces the ranking by around 3 places. So conjoint analysis can be a powerful tool in order for you to understand how different product packages are perceived by your customers. Another interesting application of data science in marketing is predicting the engagement of online ads. So there are a few different ways to do this. We can try to predict whether individual user will click on an ad, or the proportion of clicks over impressions an ad will get, or we can try to find the best ad using some techniques like reinforcement learning, which we're going to cover later. So predicting whether someone will click on an ad is a pretty common application of machine learning, and Facebook has done lots of research in this area. Here's the link if you want to learn more, and you don't really have to read the whole paragraph. I've placed in bold the most important parts, and the most important thing to take away from here is that according to Facebook and the research they've conducted, the most important part of a pipeline that predicts clicks on online ads is having the right features. This makes the most difference. And what does Facebook mean by the term right features? Well, they're mainly talking about features that contain historical information around a user. So this can be things such as the click-through rate of an ad for a given time window, let's say last week, or the average click-through rate of a user. Another interesting application of data science in marketing is choosing the best performing ads. This is related to the multi-armed bandits problem in machine learning. So I'm sure all of you must be familiar with those bandit machines in casinos. You just pull a lever and sometimes you win some coins. So the multi-armed bandits problem describes a situation where there are multiple different bandits, and each bandit has different probability of success. However, you don't know this probability beforehand. So you have to experiment and find as fast as possible and with as high as confidence as possible which bandit has the highest probability of success and go with it. So this is closely related to ads because we face a similar scenario. We face a scenario where we have different ads, we don't know which ones are going to perform best, we show them to users, we get some clicks, and we need to decide as fast as possible which ad seems to be the most engaging one. So we stick with this one. There are different algorithms for multi-armed bandits. The Epsilon Greedy algorithm is one of the most popular ones, where we start by taking random actions and then we stick with the best choice so far, but still there's an epsilon probability of us taking a random action. So this algorithm tries to balance exploitation with exploration. Another approach is Thompson sampling, which is based on Bayesian statistics. According to this approach, we have to set a prior distribution, which it can be uniform across all bandits if we have no knowledge around which bandit, or in this case online ad, is the best. And then we choose bandits in proportion to their success and we update the parameters. Again, this is another approach that balances exploration with exploitation. Here is a graph of the Epsilon Greedy approach. And you can see that in this approach, we start and we click on various bandits and we try to figure out which one is the best. That after a point, the algorithm converges to the best one. Now, when will this happen? It depends on the problem and also on the parameter epsilon. But at least there's a guarantee that if you try long enough, then eventually you're going to converge to something useful. And here is an example of Thompson sampling. We don't have to stay in this for too long. Just an example to show you how, from iteration after iteration, we start with a uniform prior across all bandits, 10 bandits in this case. And then as we start iterating, the algorithm forms some opinion about the probability that each bandit offers of succeeding. And then as we run more and more experiments, you see that eventually we get a very accurate picture of the most successful bandit, and then the algorithm focuses on this and tries to exploit this as much as possible and ignores the rest of the bandits down there. Something that gets asked very often is, are bandits really better than A/B testing? A/B testing is an alternative to multi-armed bandits, and there's a trade-off between the time taken for statistical significance and how fast and effective a method is. So A/B testing can provide results that are highly significant. If you run an A/B test, then you can be very confident in the results you get. However, you might lose many conversions until this happens. Because when you do an A/B test, you have to assign two different possibilities to two groups of users, and one is most likely inferior. Whereas with multi-armed bandits, if a choice is clearly inferior, then the algorithm will very quickly converge to the optimal solution. However, as you saw in the previous graphs, you need a large number of iterations before multi-armed bandits offer some large degree of statistical significance.